Let's go ahead and pray here a minute. Go here. Father, thank you for a chance to consider the specific ways in which we try to communicate with students mathematical ideas, the specific ways in which we try to help them become mathematicians, at least in a small sense. Pray that you'll help us as we work through these ideas to make sense, help my mind to work, my mouth to work, and the technology to work, and help us to glorify you as we do it. In Jesus' name, amen. Well, welcome. This workshop is Classical Mathematics Instructional Methods. For those of you that weren't in my previous workshop, let me reintroduce myself. My name is James Seidel. I'm the Academic Dean at Cape Breton Latin School in Topeka, Kansas. I've also been teaching mathematics, also science, meteorology, geography, computer programming, all that stuff over the course of 20 years. For the past 10, I've been working through and trying to figure out how to put into plain non-academese my master's thesis, which focused on developing a philosophy of education in a classical Christian context. So I'm excited to be able to talk with you about these ideas, to try to work through some of these concepts, some of which are going to be very familiar to you. Some of this is going to be like spring training. At least somebody's doing it right. Others of us, it's going to be something that's more new, more familiar. And in fact, before we go any farther, to help me kind of adjust what I'm doing, I know there's quite a few of us in here, but can you quickly go around, tell me your name, school you're at, how long you've been teaching, how long you've been teaching classically, and then background you might have in education or education training. You know, for instance, I've got a master's in education. I've been teaching for 20 years. Those little things, so that I've got an idea of where to hit things harder if we've got some people that are less experienced, or where to back off if, oh yeah, I know the basics. I can talk more about some of the tweaks instead. So I'm going to start on this side, though, because I'm right-handed. Yes, please.
Terry Colley. I teach at Bruno's Classical Christian Academy in Big Spring, Texas. It's in West Texas. My degree is actually in criminal justice. I have a bachelor's degree. Did law enforcement for 5.5 years, and then I switched to teaching, and then taught math at a junior high for 6 years. 2 of those I was in charge of the math department for 7th and 8th grade, and then this is my first year classically teaching, and I teach math for 4th grade, 6th grade, 3 algebra, algebra 1, algebra 2, and geometry.
Wow, that's a spread. All right, thanks.
Chandler Coleman. I teach at Sager Classical Academy. Taught about a year in classical education and just in classical education. My background's in philosophy and the application of philosophical logic to theology as well.
Okay.
I'm Cindy Blank. I teach at Neighborhood Christian Academy here in Little Spring, in Missouri. I taught 16 years at the public school, and then I taught 8 years at a classical Christian school in Belton, Texas. And then this is my first year with a new school that we just started in.
Okay.
My name is Bobby Gregory. I have a bachelor's in mathematics education with a minor in special ed. I taught for the college for 3 years at West Plains, and this is my 4th year working in classical education. The first 3 was with OCA in West Plains, and this year we started up the Neighborhood Christian School in Ozarks.
Okay.
I'm Austin. I've been teaching at Veritas Christian School for a year, less than a year. Before that, I had a master's in accounting, was an accountant, and right now I'm getting a master's in classical education. So.
My name is Charity Harris, and I teach at Veritas Christian School. I've been teaching for 5 years. I have a bachelor's in elementary education, 5 years teaching, but this is my 2nd year in hospital.
Okay.
I'm Yvonne Moore. I teach at Trinity Christian Academy. I taught 3 years at a high school in Pennsylvania and took 20 plus years off to homeschool, and so I'm back in my first year of teaching at a classical. And I graduate this spring with my master's in gifted education.
Okay.
Hi, I'm Katie Brown. Most of my educational schooling has been subbing. So I was a foster parent for 12 years, so while I was doing that, I was subbing. When I stopped fostering 2 years ago, I moved into classical education, so I don't have a huge background. It's just my 2nd year doing it, and I do pre-algebra, history for middle school, and PE.
Okay.
And I'm Molly Neesham,
and I teach at Trinity Christian Academy. I teach Algebra 2 this year. And I'm an electrical engineer. Got a degree in
Yep.
And so I spent about 20 years as an engineer and did robots and fun stuff.
Yeah.
And then somebody asked me to teach math and science because that's what I love to do. And so I've been teaching technically about 15 years, but not really. I didn't really know what I was doing.
Yep.
My name is Michael Busey. I'm from Wichita Classical School of Wichita. And background-wise, chemistry major, have a master's in Christian education, and spent 10 years as a youth pastor, and now the last 5 years have come back to the classroom and doing chemistry at different levels, 8th, 10th, 12th grade.
Okay.
My name's Angie Schmidt. I teach at the Classical School of Wichita. Also, I have a degree in oceanography and was in the Navy for, I don't know, 8 years, 6 years, 7 years? 7 years. Seems like a long time. And then started teaching in public school for 2 years, took a decade off to have kids, and I'm in my 4th year at classical school. I teach pre-algebra, algebra, and pre-calc.
I'm Sarah Moriali at OCA in West Plains. I have a master's in education, specifically math in middle school. It's a weird little
Niche.
thing
Yeah.
there. I taught public school for 5 years, then went home, had kids, homeschooled, and then now 4th year of classical.
Hi, I'm Albert Chang. I'm actually a board member at Anthem Classical Academy. I'm a professor at the University of Arkansas in ed policy. So if you want a PhD in ed policy, come in with us. We'll do classical stuff. But former math teacher, so
Okay.
I'm really curious.
Okay. Welcome. We do have a very broad range of aptitudes in here. Any hope I had of trying to narrow or adapt this has pretty much gone right out the window, which means that I have, looking at this, I have about 95 minutes worth of material then, and we don't have that much time. So I will do my best to not make this as much of a fire hose as the Computus was, but we're still going to have to work through some things because some of you are coming from the same place I was. My undergraduate degree is in meteorology. I wound up teaching mathematics because Care Paravel was desperate. I mean desperate. I failed my first interview, and they still hired me. So I had to figure out how to teach, and I had good guidance along the way, and then over time picked up the master's. And so, we'll try to work through these things. Some of you that have degrees in education, math education, I may not be able to tell you a single new thing, but hopefully there'll be something you can pick up. Some of you haven't taught a math class yet, and I'm trying to pick up some things to try to adjust your educational practice to match how you've been teaching in other classes. And so we'll try to mix those things through. Starting point, though, is going to be a very strange place. What is a cookie? You may not be able to read that, but my question is, what is a cookie? Just think in your head for a minute. You've got a picture of a cookie. See if you can kind of morph that into some wordy type definition. All right, now let's test your definition. Is that a cookie? Does that meet your definition you had in mind of cookie? Most of you, maybe, maybe not. Okay, let's keep testing it. Is that a cookie? Yeah, I usually get a lot of no's on that one. But we could sit here. And then what about that one? That's a cookie. That is a cookie, but it certainly isn't like the first thing that most of us would agree and most kids would agree is a cookie. See, words are tricky to define sometimes, and sometimes there's aspects to words that will work, but we don't think of that aspect, and you wind up getting in arguments. In fact, in the 1980s, Procter & Gamble sued 2 other baking companies for infringing on a patent for dual-textured cookie. Part of the argument was about whether they could define, and the judge, that's the judge to do it, and he said, I'm not doing that, wisely, because that would put his thumb on the scales, define the word cookie. Took them years, and they finally just settled because they couldn't agree on the meaning, among other things, of the word cookie. Well, we face that same problem with classical. If you've ever gone to the ACCS conference, if you've gone to different conferences, this one, others, you talk to two different classical educators. They will all define classical a little bit differently. Classical education is like a diamond. It's got a lot of different facets, a lot of different angles, and the light will play through differently depending on what you want. And so, classical, this is the first thing that pops in my mind when I think classical math, right? I picture the School of Athens in my head, right? And if you've been to workshops on teaching classically, right, the basic tracks, right, or somebody's just brought you into classical education, they say, yeah, just teach grammar, logic, and rhetoric. Okay, and like Euclid, you're like, what? What do you mean? What does that even mean? What does mathematical rhetoric even mean? I'm gonna have to wrestle with that. And could we have rhetorical mathematics? I mean, could we go backwards with that? All side notes. My point is, it's kind of like saying, here's a block of marble, make a bust of the President of the United States. Just use a chisel and hammer. That's true. You're gonna make a statue with a chisel and hammer, but how? How do I hold the chisel? At what angle? How much pressure do I use with the hammer? Most of us aren't Michelangelo and can just take off what doesn't look like the president. So we have to talk in more detail about what it looks like to chisel our students, what it looks like to chisel away the stuff that doesn't work, what it means to teach classically. What does it mean by classical? And so our starting point today is going to be getting a working definition of classical Christian education, which will require us to delve quickly into the history of education, really quickly. This whole defining classical Christian education is about an hour and a half or 2 hour in-service by itself. Trust me, I've done it before, and it's actually really fun, but we don't have that kind of time. Then we're going to look at three modes of classical Christian education, and it's probably not going to be what you're thinking. And then we're going to look at some various methods of teaching classically, but they are going to be just the tip of the iceberg. Because there are, if you've had a math methods class, you know it's a semester long worth of ways you could do things. Some of them really clever, and some of them clearly thought up by a professor who's never taught anybody below the age of 20 in his life. So a little bit of each. Let's start with our working definition of classical. From at least the Middle Ages until the 19th century in Europe, and in America to some degree, you didn't need to say Christian with education. General education was basically, and I know there's exceptions to this, I'm painting broadly here, it was thought of as knowledge of its creator. You were learning about God and what the world had made. With the advent of scientific education, especially in Germany, that rose up, and so there was more, everything had to be tested and proved the same way physics tests stuff. And progressive education in the early 20th century with Dewey, that idea just disappeared. And so now we have to say Christian school in most cases, and most of you are at a classical school or a Christian school in some way. Well, we would call that instead a liberal arts education now. That's probably the better description of what went on in the Middle Ages, the phrase liberal arts education. This was rooted in ancient Greece and Rome, but it built on it. It didn't imitate what they did in ancient Greece and Rome. They stopped beating their students, for instance, but it would be called a liberal arts education. Okay, I just threw the phrase liberal out. That's a loaded word in 21st century America. Maybe you've studied this before. What do I mean when I say liberal in liberal arts tradition? Angie? Liberty, so she's using a cognate, same Latin root, liberty. Liberty means freedom. Okay. Freedom for something, from something, to something?
To.
Freedom to what?
Do whatever.
Do whatever. Okay. Any other ideas of what he might?
Very striking resemblance to like classical liberalism, the role of the individual and participating through critical reasoning.
You guys get that? Classical liberalism, the idea that an individual is able to be free to be as he needs to be, maybe if I can rephrase that, without interference from government, without interference from an external source. Okay? We usually use liberal to mean as generous, right? Apply a liberal amount of sunscreen, right? That's not the tax and spend liberal amount of sunscreen. Or liberal as in left of center, right? Those are the two meanings in 21st century America. Neither of those is what this means. It's closer to free. But let's dig a little bit more into this idea of free from a 12th century monk named Hugh of St. Victor. He was an early scholastic. In his work, the Didascalion, I got it right, it's not easy to say, he wrote the following, among other things. Out of all the sciences above named, pause a moment, when Hugh says science here, he means knowledge of any kind. That's what they would have called it in the Middle Ages. The ancients in their studies especially selected 7 to be mastered by those who were to be educated. These 7 they considered so to excel all the rest in usefulness, that anyone who had been thoroughly schooled in them might afterward come to a knowledge of the others by his own inquiry and effort, rather than by listening to a teacher. For these, one might say, constitute the best instruments, the best rudiments, by which the way is prepared for the mind's complete knowledge of philosophic truth. Therefore they are called by the name Trivium and Quadrivium, because by them, as by certain ways, the Latin there is via, a quick mind enters into the secret places of wisdom. So these liberal arts were the arts that freed the student to learn on his own, without the need for a teacher, without the need for a book, instructor, free to be on his own. And they consisted of these 3 ways: the trivium, which we're very familiar with. When classical Christian education came back on the scene, the trivium was heavily emphasized. But there are also the 4 ways of the mathematics: arithmetic, geometry, music, and astronomy. And these 7, if you knew these 7, you could proceed into anything else they would study in the Middle Ages. In most cases, it was theology and philosophy, because the monks were the ones running the schools. And so they were training people to be priests and monks. But you could move into law, you could move into medicine. Those were the main fields then. But the idea was that a student was able to be trained in these arts and then was liber to learn anything else without a teacher. And I would say apply as well. Learn and apply without a teacher necessarily being directly there. Or to put it in completely modern terms, a student could learn independently and be able to love the Lord his God with all his heart, soul, mind, and strength, and love his neighbor as himself, without constantly having somebody else, hey, you need to do this, you need to do this. Self-regulated, we might say in fancy psychological terms. Okay, mini discussion break. Turn to your neighbor. Say what the 7 liberal arts are. Hopefully you're taking notes. If not, this will help you remember it. And then why again are they called liberal? Call you back in a minute. I'm going to say the phrase focus front. Focus back up with me. Go. Not at all. Focus front, please. Focus front. Focus front. Focus front. Yeah, the quadrivium by itself is a whole nother discussion because there's several ways the ancients, Hugh formulates it in a strange way. The ancients formulated it in different ways, and Hugh of St. Victor was a brilliant philosopher, brilliant theologian. I'm not sure if he was the best mathematician or scientist, and so sometimes we need to build with it. But that's not where we're going. We're trying to stay a little broader for the moment. Here's my working definition for classical Christian education. The idea here is we want to build on something out of the liberal arts tradition. All classical Christian education, regardless of its emphasis, and there are a lot of strands of classical Christian education. We always think of, a lot of us might think of Douglas Wilson and Moscow School, as being classical Christian, but there's the Integrated Humanities program out of KU. Our keynote speaker this morning referenced John Sr. He was one of the main Integrated Humanities program guys, helped contribute to founding the school. Sr. didn't, but people that studied under him founded the school I was at. So that's that thread. You've got David Hicks, who focused on the morality aspect of classical Christian education. And there's some other authors, Littlejohn and Evans, who focus on adjusting the liberal arts idea to the 21st century and expanding it. So there's these different facets. They don't all agree on the same definition of classical Christian education, so we need something that we can all agree on so that we're not arguing about cookie. Here's my definition again. Classical Christian education cultivates faithful disciples of Christ who will engage in a lifelong pursuit of wisdom and wonder by providing them with the tools of learning via liberal arts education, in order to allow them to know Christ and live Christ-honoring lives. Now, that's a big definition. And I probably left something out that you would really want to put in. There's probably something you want me to emphasize. that's the nature of classical Christian education. It is a very broad thing because we're in this broad liberal arts tradition. And so we have a lot of those things that we're going to try to pull together. Put it into the mathematics classroom to narrow it back down a minute, I would say that we are trying to develop students who will be able to have the intellectual, moral, emotional, psychological, and sometimes even physiological tools needed to be able to learn independently and apply independently mathematics to the glory of God. And so that's kind of what mathematics in a classical model is trying to do. Now, I took us through that, and that was very brief, because I can't cover every possible method of instruction that you'll encounter. And so you need to be able to evaluate, hey, does this method, I like how it works, is this working classically? Could I be doing something more classical that would work better? Could I be doing something that's more Christian? And so now you've got a bit of a framework to evaluate what we're doing. I think that's helpful since I can't cover everything. And I want to look now at a breakdown of the classical modes of instruction, one way within the liberal arts tradition that we can group methods in. And I'm going to be following the work of Mortimer Adler on this, rather than following Dorothy Sayers or someone else. We're going to follow Mortimer Adler. Those of you who have education degrees have probably read Adler. I remember reading the Paideia Proposal when I went through my classes. And the Paideia Proposal is an interesting read if you're teaching in Christian schools, because it's targeted at public schools. And so you have to read between the lines in a lot of cases to see the classical stuff. It's there, but he's being sneaky about it. Too bad they didn't adopt it. It would have really revolutionized the public schools and made them, well, in my opinion, a lot better. You can disagree with me and pass the class. Adler has three different modes: didactic, memetic, and Socratic. And Adler's not the one who came up with this. This has been a long-running way of grouping things, and he's not alone in doing it. These modes, however, do not correspond exactly to grammar, logic, and rhetoric. I probably could get into a heated debate with some people about that point. I've seen some people presenting that will say this. I'll explain why I think that in a minute, but the basic idea of grammar, logic, and rhetoric, when you're thinking of it as methods, is that grammar is about facts or information, logic is connectiveness, connection between facts, and rhetoric is some kind of expression of those facts, preferably eloquently. That's not quite how didactic, memetic, and Socratic fit, but we'll pull that through more in a minute. I pulled this table straight out of the Paideia Proposal almost, adapted it. I apologize for the top of it being completely illegible, but at least it's there. The idea here is that we've got these three modes, and we'll be walking through these briefly in a moment. What you need to grasp and hold on to here is that didactic, you notice it's lectures, textbooks, other aids, and it operates in, well, everything. You notice that list there, that covers what most people consider the entire curriculum. Memetic is coaching, exercises, supervised practice. And again, as we look through this, we see a lot of things, but we see a lot of stuff that falls in math and science within the memetics, within the memetic methods. And then finally, Socratic, which I know some of you can't see this over the board break, but it's Socratic questioning, active participation, discussion of books and textbooks, works of art, involvement in activities, and you may notice something's missing. We'll come back to that. The three columns, Adler says, do not correspond to separate courses. Okay, you're not going to have a course in didactics. You're not going to have a course in memetics at all. And one kind of teaching and learning is not necessarily confined to one class. In other words, history class is not solely didactic or solely memetic. Performing arts are not solely Socratic. Rather, all of these occur in all the classes. Adler would say the first two always occur, and the second, except in math and science, occur. Again, we're going to talk about that. Didactic methods. Quick summary of this again. This is transmitting information. I'm didacting right now. And it's not a verb, I know, but hey, it's the 21st century. We can now verb our nouns all we want. Didactic methods transmit information. You're trying to acquire and keep that knowledge organized. These are the telling methods. These are the ways in which students know that something is true. So lecture, but also reading, these sorts of methods. There's actually other methods that you wouldn't normally think of that fall in here. Early stages of, say, discovery learning, where a student's asked to do something. That could almost fall in didactic, although that may belong in Socratic. So sometimes methods will bridge across things because they're more complicated, but this will help us organize our thoughts. Memetic methods. Mimic. The student mimics what the teacher does. This is huge in writing. You think about progymnasmata, or some of the other writing tools, workshops, and writing curricula out there. What's the one? Not Kern, is it? I'm trying to remember. Excellence in Writing, I think, does this. Lost Tools of Writing does this. A lot of the classical tools of writing do this. They use imitation. Adler calls it coaching. If you've ever coached a sport, like I know I have, you do a lot of this, right? You are trying to teach a step over, right? You do it, or you probably have a player do it in the case of a step over in most cases, so you don't fall. And you have them do it, and then you have them, all the players do it, and you walk around, making sure they're doing it right. Tell them, oh yeah, shift your weight a little bit more. Make sure you get that foot a little farther out so you don't blow your knee out, all these sorts of things. These are ways students know how to do something. So didactic, that sounded a lot like the grammar of the pedagogical mode of the trivium. Memetic modes don't sound like logic at all, because they're not. They're actually grammar methods again. It's still really it's facts still. It's just facts about your body, or your mind, or how you do something. It's an outward motion. And so, yeah, it's more how to. The why, that's logic, and the expression of things, that's rhetoric, that's Socratic. Socratic methods push students into higher levels of thinking. Adler calls it, in fact, large understanding of ideas and values. Teaching participants how to analyze, as well as analyze their thoughts of others. Disciplined conversations about ideas and values. There's a fancy two-word name for this that I'm going to get to in a minute. But it gives us an idea of what they are as we work with these ideas, trying to understand how people think, how you think, how others think. That's how Adler sees Socratic methods, which may be part of why you understand why he might have had trouble thinking of math in this way. Think about how other mathematicians think. Think about the values of other mathematicians. Are we talking like absolute value? What does he mean by that? Well, again, we'll talk about that. Mathematics and science, he says, really they don't fit into the Socratic bubble the same way. And so he doesn't think they can be taught with Socratic methods. He's wrong, by the way, I think. We'll talk about why momentarily. He doesn't think they connect to what's called the Great Conversation. Okay, the Great Conversation, let me jump to that. It's what Adler was just talking about, the discussion of the foundational ideas of what it means to be a human being. It's the discussion of worldview questions. What does it mean to be a human being? What is the nature of humanity? Are we born innocent and become corrupted by society? Okay, we're bad, we're fallen, we're imperfect. What does that mean? What is our greatest need? How do we meet the greatest need? What's the good life? How do we live it? Right? These questions that are philosophical or theological in nature, that everyone from the ancient Greeks all the way up to people today are asking, whether they realize it or not. That's the Great Conversation, and everyone's attempts to answer it have been recorded in works all the way from Aristophanes all the way up to, people today, people writing fluff work like Star Trek Picard or whatever, I mean, they think they're trying to answer the Great Conversation in some cases. They sometimes don't have a whole lot to work with, and so, in case of modern television, but they try, bless their hearts, in the Southern sense. No, kidding. Math and science now don't seem to connect to the Great Conversation, but let's be honest. Literature doesn't directly. Music doesn't directly. History doesn't directly, unless you go through philosophy and theology, right? I could read The Lion, the Witch, and the Wardrobe. How many of you read The Lion, the Witch, and the Wardrobe as kids and missed the whole theological point of it? Me, right? Because we didn't apply philosophy or theology to it. We just read it as a story. So unless you're in philosophy or theology, you don't really get into this a whole lot. And so the integrative disciplines of theology and philosophy can help us. They can help us get to the bigger questions. I hate to use the word meta here, but that really is the right word, the meta questions, the questions that overarch all the other things. And so Adler doesn't quite catch this, but he's a humanities guy. I'll give him a break. Give him a lot of break. He's a sharp guy, smarter than I am, and so I don't want to speak too badly of him. So Socratic methods do have a place in mathematics classroom. Absolutely. And in fact, on two different levels. We can explore mathematical ideas the way philosophers explore philosophical ideas. We can ask questions, and we'll talk about that in a minute, about how we could do that. You could start with prime numbers and start working to Goldbach's conjecture and the various levels of Goldbach's conjecture until you get to the ridiculously strong Goldbach's conjecture, which says there are no numbers. That's a little too strong. Or mathematicians are all laughing and everyone else is going, huh? Nah, don't worry about it. But we could also take a mathematical idea and build it out and ask questions that are worldview questions. For instance, you could use probability, something everybody studies in math class. Build that to expected value. Apply that to playing the lottery or not, and then have a discussion and debate. Mathematically speaking, is playing the lottery a good use of money or a good idea? Okay, that's a mathematical question. Second, is it then a good idea for us to have a lottery or not from a mathematical perspective? Well, let's take it one step farther and talk about it morally or from a worldview. How can what we say in mathematics inform that discussion and debate? And it leads to a lot of debate and discussion because it's not a simple issue. There's a lot of things that go on to this. You and I had a conversation about this years ago, I think, but about the lottery.
Yeah. Mm-hmm.
We did, and I'm not going to get into that now because it doesn't matter. But what we're doing right now, does playing the lottery help someone live the good life or not, right? And this is a question that's obviously huge. And we started with a question of probability. If you flip a coin one time, what's the probability of getting heads, right? So you can build that, but notice I went through philosophy, I went through theology to get to those bigger questions into the Socratic reasoning. Whereas the first case, I just was asking a philosophy of mathematics question. Delve more into that in a minute. Let's go to didactic methods. And let's switch gears and be practical about this a little bit. Let's start trying to get into what I'm doing in front of my students on a daily basis. So these are didactic methods of instruction. As math teachers, these are probably, didactic and memetic are the main types of methods we use in most of our classes. We just do. Now, you're probably all using this. You've all got different backgrounds. Some of you have a lot of detail. I'm about to say stuff that you've heard 100 times. Some of you, it's like, oh, okay. And some of you, it's like, okay, get on with it. So bear with me if you've had a lot of background in this. I'm trying to capture the median of the class, not the mode. So lecture is our starting point, though. From the Latin word lectio, meaning reading. And quite literally, that's what it was. Somebody would get up, a monk, would get up and read a book, and everyone else would be furiously copying it down. This is before the printing press. The idea was then you would take that book and you'd study it on your own time and consider it and work it through. This transformed when universities started to develop. That lectio became a presentation by a qualified professor, so you went from an unqualified person reading something to a presentation by a qualified professor to, in some cases at large universities, unfortunately, you now have an unqualified TA doing a presentation. Not always, but I had some, yeah. We won't talk about my physics classes. They were, interesting. Lecture is most frequently used in college classes, in your math classes, right? Those of you who have math degrees or took math classes. You had a professor that stood up there and just talked for 50 minutes, talked and worked examples. There was no interaction with the class. There were no practice problems. You just were talked at. And the idea was you were going to go take that and work it on your own. It was back to that traditional lecture method. But we tend to teach the way we were taught, which means that what are we doing? Lecturing. There is nothing wrong with lecture. No, I'm serious. There is absolutely nothing wrong with lecture. I, perhaps being overly sensitive in this area, feel like I go to workshops every year and I feel like I've got somebody saying, don't lecture, use this method, use group work, use discovery learning, and that's the only way you can teach classically. And they may not say it, but I feel like it's implied in some cases. And that's not necessarily the case. It's not evil to lecture. It's not wrong to lecture. It's very classical to lecture. What do you think Plato was doing? Walking around, he was lecturing. His students were desperately trying to keep up with him in every sense of the word. But lecture, as great as it is, there's times where you have to transmit information to students. When I taught physics, we covered Newton's 3 laws of motion. I don't have time in my physics class to have students take and do all the work to mathematically develop all 3 laws of motion. We don't have time. It took Newton years to pull that stuff off. And especially for wanting Newton's formulation, you're not going to get there because that's calculus. But if you need to delve into it, maybe you need to tell them something. There's things that students aren't just going to come up with in mathematics. I think about trig ratios. Are you going to come up with sine of theta all on your own as a kid? I mean, you're going to have one kid every 10 years who might just grasp the sign right away, and see it ahead of you, in which case you should hand him the marker probably and let him take over. But No, that's times to tell them things. But don't mishear me. Lecture is classical. Lecture is Christian. It's not an issue of if you lecture. The issue is whether you're lecturing the right amount. Uh-oh, that word, dangerous word, right amount. What do I mean? Leaving that purposely vague. Because it's going to depend on you as a teacher, your students, the nature of the material. All are going to define how much you do it. If you're familiar with the 7 laws of teaching, there's the adage, don't tell a student something he could discover by himself or figure out by himself. That's true, but that doesn't mean that John Milton Gregory was saying, don't tell the student anything. Sometimes a student can't figure it out for weeks. You might need to help that process along a little bit. And there's ways to help that process along without lecture. And we'll get into that. But sometimes you just need to lecture. But I think we'll agree with this probably. No one's going to say, I just want to lecture my whole class. I don't think anyone at this level is so self-important. We're, no offense, not college professors. There are college professors that love to hear themselves talk. I had some of those in meteorology, if you can believe it, which you wouldn't think would be the case. Psychology professors are actually the worst about it, but that's a different story. Lecture should not be your totality of class. We should mix them. In fact, most of you, if you teach and think about how you teach, you're lecturing, and then you mix other methods in. It's like you've got lecture, and then you go off and you do something, you come back, a little more lecture, oh, you go off somewhere else. And so that's what we're going to do. And that's actually what I want to talk about is ways we can break up lecture. One way we can do this is called power teaching, or whole brain instruction it's called. Stumbled across this method in my master's classes. This breaks up teacher talk. What you do in pure power teaching a minute, and I don't know anybody that actually does that, very few people that actually do this. You only lecture for 45 to 60 seconds. And then in the next 45 to 60 seconds, the students all do what you did when I asked you to summarize the 7 liberal arts and explain why they're called liberal. They tell it to themselves. You pull the class back together, like I did with Focus Front, and you repeat the process. If you've got a very playful class, you can do things like, say the code phrase was class. You go, class, and everyone can respond back, yes, or that kind of thing. With playful classes, that actually can work. Elementary school kids would love that. I had one class at Care Paravel I did this with. They were so playful. I actually did that with them, and it worked for them. It was a huge class that wouldn't shut up, and so that's how I got them to, I worked with the grain a little bit. But it works pretty well, but a whole period of this would be overwhelming. You could use this, I think, in geometry with theorems, postulates, things where they've got to repeat something, because that's the nice part about this. You get some instant rehearsal. You get some instant repeating of facts. Again, the idea is just to help them get those facts to stick a minute before you do something with them. Use it in pre-calc, exact values. Sine, cosine, tangent. I have a class this year that could not get the exact values to save their life. I probably should have done this if I'd been thinking, but unfortunately I failed. I did not. So I did not do a good job. I had to work harder because of it. Notice I have up here a full period is overwhelming. Yeah, if you teach 90 minutes, I don't know. If your class is maybe only 45 or 60, probably more doable. 90 minutes of it? No. I did it. I taught all 3 laws of motion this way. Newton's laws of motion. I was exhausted. And that was second block. I still had another block. So pick your methods, obviously, but it works well. Grammar school students will work well. Or shorter periods of time. Do it as part of your class. Or pick it for one topic and do it. And this can work. Although there's one more thing we can do. Let's go medieval and do a little allegorical approach to this. Let's not do literal power teaching. Let's just use the idea of breaking up your lecture with something else and plugging something else into the gaps. There's a couple of things we can plug into those gaps besides teacher talking, teacher prided example. One is memetics, memetic methods. Memetic methods are the practice, the skills practice ideas. How many of you in your classes do some kind of practice in your math classes, right? Most of us, right. I mean, that's just standard. And that is the first method I want to briefly talk about, example and practice. Now, examples aren't memetic. You do an example by yourself, students aren't imitating anything unless they're really tracking right with you or a step ahead of you in the example. And I have a class that's like that this year that is always ahead of me on the examples. It's really easy to teach as a result. But most of your classes aren't that way. They're behind you a step or two. And so they're not imitating. Their minds aren't really full speed engaging. But if you mix student practice, it reinforces the concept and can help reduce student confusion on homework. Can help reduce student confusion on homework. It does not get rid of it. It can't. Learning is a process, it's work, your mind gets confused. So these memetic methods, when you pair examples and student practice together can work. These are separate from homework though. Okay, homework is a practice, homework is memetic, but I'm thinking of in-class memetic work. You can grade it, you cannot, right? That works fine, I think very familiar to us most. Here's the one place where I'm gonna say something that some of you may disagree with me on, and it's okay. I'm gonna argue that student practice should immediately follow each example. I've done this both ways, where I wait till the end of the class and then do practice problems. What I found is that if you do that, they've forgotten the skills from the start of class. So, and this has become more common. Now in the last 10 years, I've noticed even books start to do this now more. That you do something and then you ask them to practice it right away. That allows them to reinforce the thing you've seen. Now you can also extend a little bit with the practice problem. You don't have to have them, you don't have to just change the numbers. You can do a little extension, a little twist, make it a little harder, especially if you feel like they're with you and you have to know your class. But you can do that, and then on homework, you can maybe take off some of the really basic imitative ones and go a little farther if you want. But student practice should occur in class, it should occur outside of class to help reinforce things. You can have little whiteboards, right? If you've got something that's got very numerical answers, that's great. If you want to do it, paper is fine. But here's what I found, and you've got probably some experience and some thoughts too. Unfortunately, I don't have time to solicit them. We're gonna have to keep moving, I'm sorry. Some things I found. This first one, I'm reminding myself of constantly now that COVID's settled down. Walk around during student practice. I became a statue during COVID because we're all supposed to stay 6 feet away from everything. Maybe some of you didn't do that. I did. And so now I'm like, oh yeah, I need to walk around because students will ask you questions when you're close, but they won't ask it in front of everybody. So walk around. Some things I've seen with teachers that try practice problems, they give too many at once. 1 to 2. Don't do more than that because you know what's going to happen then, right? Timmy is really smart, blows through them all, and is distracting Susie, who needs to be able to focus, that kind of thing. Do go over your practice problems with students. We had a teacher at our school that didn't do that. She assigned like 4 at once and only 1 over 2. It's like, ooh, no, break that down, slow it down. I mean, students need that reinforcement. And manage your time as well. If you find that you're always chasing time, you may be losing time right here and too much time for practice problems. Give them 60 seconds to do a problem you know is going to take them 2 minutes. Tell them it's 60 seconds. Actually, give them 2 minutes, but tell them it's 60 seconds. Try to keep them moving. You know, what you need to do, you know your students, right? Some students, you don't need to give time. That sort of thing. Don't be afraid to pull your class back together. I see teachers that are afraid to pull the class back together when they're confused. That's odd. No, pull them all back together. If they don't understand what you're doing, pull them back together. Use it as a second example. Maybe follow up with another practice problem. But don't be afraid, just like a coach. If you're a coach, you know coaches do this. You try that skill. That was terrible, a coach says. Let's go over how we do this and let's all do it again. That kind of thing. It's really critical for developing mathematical skills. And we can do a couple other things memetically. I'm going to have to be quick with this. Board work. This is where you call a student up and they explain the problem on the board. Now, board work has positives and negatives. A lot of teachers do this for practice problems or for homework problems. This is great for helping with rhetoric skills, and it helps with learning something, right? If you have to teach it, it can sharpen your focus and help you learn it. But think about your student who doesn't like to do math, or your student who's afraid of talking to people. Right? Even seniors in high school, even my sharp seniors in high school would probably have trouble and not feel comfortable doing this. And so you got to be careful, and it is time inefficient. So you want to make sure that you don't try to do this too much, or else you're going to wind up chasing things again, right? So like every method, pick it. Discretion is advised. Choose your students wisely. Make sure that no matter what, you've got a culture of support and encouragement. That should be always the case in your classroom, right? Love your neighbors yourself means that if somebody's trying something and they say something wrong that's just blatantly wrong, you know, the absolute value of a number is the number that it is. I'm not even sure what that means, but you know, okay, John, what's Susie say there? Can you translate Susie's definition into different words? You know, that kind of thing. And some of us have done this a lot and are pretty skilled at doing it by now, or think we're skilled at it. You know, I'm going to go back to class on Monday and probably botch it, but that kind of thing. Mix in things like inverse board work. We'll talk about that in a minute. Let the student up front phone a friend, right? Maybe one of your best students is up presenting a proof, and they get part way and then they go blank. Oh, well, ask a friend to help you. Have 2 students work together. Have them work competitively. In certain situations, a little race to finish a problem might not be a bad thing. You got to know the material and your students to pull that one off. And please, just as a friendly reminder, correct your erroneous student presentations. Don't let the wrong answer work out. Now, one interesting idea, something weird you can do with board work. Warn your students ahead of time if you're going to do this. Tell them they're to present a homework problem, an idea. I think of geometry, especially in this. Students, you're going to come to class next time, and I want you to be ready to explain proposition whatever of Euclid. Or students, you're going to come to class and explain how to do synthetic division with this polynomial, right? And have that set up, but maybe reduce the total number of problems you're going to do then. Don't assign 20 problems if you're going to ask them to also prep to explain, because they're going to have to take some time to do it. And if your school doesn't do a lot with rhetoric presentations and presentations in other classes in this way, be really explicit modeling what you're doing. Things like, all right, as you go through an example. So my first step here is this, and I want to make sure I explain all of my thought process. And then as I'm explaining this to you, what I'm going to do is go, you're always told not to do a play-by-play as a teacher of what you're doing. If you're trying to expect a student to present, you might need to do a little play-by-play at times. Students are notoriously dense when trying to take an idea from one class, rhetoric, and move it into another, mathematics. So be a little, now's not the time to be clever or smooth or eloquent. In this case, it can be a little ugly, a little raw, and that's okay. Now, I mentioned inverse board work. Let me quickly talk about that before we switch gears into the Socratic. Inverse board work, and again, I stole this from my graduate classes. The person at the board's just a scribe. That's why it's inverted. The person at the board doesn't do anything unless you allow it. And this class has to tell the student what to do. This is great if you want to pull that one student up who kind of sits there and is mousy. You can get that student to engage, and the class can present what's going on. And it cuts down on you talking, of course, which is always nice, and can engage the class. But you still have to watch it. Like anything where you ask a class to do things, you always got those wallflowers that are going to try to hide. Don't let them hide. Just like when you ask questions, which we'll talk about in a minute, you've got to make sure you pull people out, and it does take time in a lot of cases, especially to pull a student up. One of my favorite ways to use this, and I do like this method, I'm biased, I will give them a practice problem, and I'll be the scribe. And I will have the students tell me what to do. Some of you probably do this. You didn't realize I had a name. Yeah. So it's I think it's a fun way to mix things up and get students explaining things without having to take the time of pulling someone up and worrying about whether they remember how to write the notation. And then if you're the scribe, you can interject if everyone gets stuck as needed. And not, of course, everything works with this. So those are a couple of memetic methods. There's other ways to do mimesis. There's other ways to get them to imitate things, have them actually imitate great mathematicians, that kind of thing, have them read something out of Leonard Euler's algebra book and try to imitate it, and that kind of thing. All other things could do. If you really have a situation where you need to do this, award participation points. I don't do participation points, but maybe you need to. Every student, every class, every school environment is so different. So all very interesting. And I want to, in our short time remaining, to cover a couple of things. Socratic methods. We don't use these a lot in math class, although we may use them more than we realize in some cases. Yeah, I know, completely contradictory. Stick with me. These are methods where we discuss an idea or concept. And one of them, well, who doesn't love a question? In fact, the story goes that a rabbi asked his teacher, "Rabbi, why do you put your teaching so often in the form of a question?" To which the rabbi replied, "So what's wrong with a question?" Okay, so questions, they're great. They engage the mind. A good question can really get a class moving in the right direction. It doesn't take, you can start a class with a question and roll with it the entire class if you do it right. Used poorly, well, it becomes a painful slog. So, good questions. Reminder about what makes good questions? They require completely higher level thinking. Bloom's taxonomy, right? Remember, understand, those are lower level thinking it's called, takes less involvement of the mind, whereas apply, analyze, evaluate, create. These require a lot more complicated and complex thinking, more involved. So those tend to make better questions, in general, of course. Good questions have generally defined answers, or you've got an idea of where they're going, related to the content, not the teacher's thinking. Right? The guess what I'm thinking question, you've all been in classes where the teacher is asking you something and it's basically to guess what they're thinking. I hate that with a passion. And I hate it when I do it. And I do it sometimes. It makes me so frustrated with myself. I'm like, couldn't you have asked a better question? Come on, dummy. But maybe that's more of my inner monologue than you wish to know about. I don't know. And not rhetorical. I will mock myself for using rhetorical questions if I use them too much, with a phrase something like to the effect of, I'm so glad I asked that. Because there's nothing wrong with a rhetorical question here and there, but when your whole class becomes rhetorical questions, when you ask a real question, students aren't going to be sure if it's rhetorical or not. So that's why you want to stay away from them. Now, I know I said good questions generally require higher level thinking, but there's nothing wrong with a basic recall question. Sometimes you have to do the basic recall question to get to the higher level question. Just the way it works. And we can use questions in discussions, but I want to talk a bit about questions here in a minute. Not all questions are Socratic. A non-Socratic question focuses just on the lower levels of thinking, such as, what is the derivative of cosine x? It's not really a Socratic question the way Adler defined it, right? We're not enlarging understanding of ideas and values and worldview by recalling that derivative of cosine is negative sine. Where Socratic questions move to those higher levels, they dig in a little more deeply. I referenced this earlier. From a mathematical perspective, why might playing the lottery be a poor idea? Right? That's a question that's going to require you to take some ideas that you've seen and explain and analyze a little bit, so higher up. Nothing wrong with non-Socratic questions, but if you're going to do questions, last thing quickly, because my time is short. Wait time. Remember this from your education classes? Wait time. Ask a question and wait, and deal with the awkward silence. A really complex question might be, you might be standing there for a whole minute. And it's not because the question was bad, it's because the students are wrestling with it. So don't be afraid to wait, but do be aware of your class. And if they're truly just sitting there confused because they have no idea what you just asked them, you need to adjust some things. So rephrase your question, narrow its scope. And one more little hint I'll give as I'm trying to speed through this to get to the math discussion, which is really interesting. My Spanish teacher had a cliché, si no hay voluntarios hay víctimas, which looks pretty much like what it says. If there are not volunteers, there are victims. So if a student's not going to volunteer, you call on them. And I will do this. I will pick on students. But the student and I have a deal. I mean, it's a tacit deal. Most students realize this quickly. They can say, I don't know. Now, I'm going to follow up that I don't know with, okay, so what's confusing you? What don't you understand? Where are you stuck? That kind of thing. But you can do that. If you didn't realize that, or if you haven't done that before, try that. You'll find that you can build, if you build the right culture, your students will start to work with you. And it helps develop what's called metacognition, the thinking about their thinking, which students that struggle don't think about their thinking. I mean, they do think, just not about their thinking. Well, and one student, no. And do keep the conversations down, because how many of you have had this, right? You call on a student, and everyone else tunes out because you called on the one. Yeah, you just have to. That's a classroom management thing. That's how it goes. Okay, math discussions. Math discussions, you can do these in as little as 5 minutes. You can just drop out of your lecture or drop out of your examples for 5 minutes and talk about something. I'll explain how that works in a minute in more detail. Or you can take a whole period and delve deep into some ideas out of mathematics or expand it outward using philosophy and theology and get into the great conversation about something. So, and you could even do it mathematically. Why might Goldbach's conjecture be difficult to prove? That's a good question. What is Goldbach's conjecture? Well, you've got to establish that first. That's where lecture or example or whatever comes into play. And then build from there. Or here's a geometry one. If a figure has two equal sides, then it is an isosceles triangle. Is that true or false? And explain. You'd be surprised how many students get this one wrong, because it's false. We don't have time to talk about that right now. Is mathematics discovered, invented, or both? Right? These are all things that stay mostly in the mathematical realm. That last one starts to edge out. Or you could do great conversation discussions. How does the Fibonacci sequence connect to evidence for the existence of God? If you've done the prep work on this, you can delve into this. And this goes some really weird and interesting places. Or how does the knowledge of probability help me live the good life? Right? Probability is a great one just because it's very practical. And so these are all things we could cover. And discussions, again, they don't have to be long. Philosophy and theology can help. And you can build outward, again, using philosophy and theology as your integration point, as your touchstone to broaden it out. Different teachers will do things differently. In fact, I can think of 3 different ways that you can do this. A class period every quarter or semester. I know teachers that do this. They'll have a day. Students will do a reading. They'll come to class, and they'll go over stuff. I tend to mix things in here and there. So if we're talking about the idea of infinitesimals, we might talk about the history of math where the debates between the German mathematicians that thought infinity didn't exist and the mathematicians that thought infinitesimals didn't exist. Okay, what does that mean? Why are they basically saying the same? They're both contradicting themselves because they're really the same thing. I know it sounds crazy, but they pretty much are. And etc. Sorry, lost my train of thought there. I was lost in infinity. And then some teachers, I was talking with a guy down at a classical academy in Atlanta named Sam Clausen, and he says he likes to start his classes with a Socratic question based off something they've just done. And then he guides his whole class by using that one question to go. Some teachers can do that, some can't. If you're not one that feels comfortable doing it, don't do it. But if you want to try it, try it. It's very interesting. Now, this is not normal. Leading discussions is not normal for us. We don't do this. We don't do people, we do numbers in a lot of cases. So this can be a challenge. So here's some things I'd suggest very quickly. Study, learn how to do it. You're teachers, you've learned how to teach. Now teach yourself. Learn how to do it. Talk to some teachers who are good at it. Observe them. You probably have got some discussion classes at your school. It's a classical school. There's people that do it. Establish ground rules so that students know how things work. Talk to those teachers that do discussions. Kill the wabbit. Keep those rabbit trails in control. Those rabbit trails down. You may need participation points. The biggest thing I would say is if you're going to do a long discussion, give them a reading ahead of time. Give them something to discuss. You've thought about this for years maybe. They're not going to come up with anything interesting in 5 minutes because you probably wouldn't have either. Some places to go for that. Ravi Jain is an author that does a lot on philosophy of mathematics and science, so he's a pretty interesting place. If you've ever read the book Mathematics, Is God Silent by James Nichol, that has a lot on the history of mathematics and how it connects to worldview, and you could drop in a lot of places. Pull a small reading and go. Pascal's Wager, if you remember, if you studied Pascal's Wager, that ties into probability nicely. Talk with your literature, history, and Bible teachers. There's all kinds of places you could go. If you want more, I could probably throw another 4 or 5 ideas out of classical antiquity, out of history that you could pull out of the history of mathematics to read an author and discuss him in more detail. Okay, I am really pushing my time. I knew this was going to happen. I gave you that sample lesson. Those of you in my Computus workshop know I like to do sample lessons that are the kind of education professor would love and no teacher could ever teach from. That's what this is too. This is showing you how I could take every single method we just talked about and jam it into one single lesson, just to try to give you an idea of a way you could do it. So, I've got lecture to present ideas. I've got math discussion marked there in places like C6 and C7. You could use power teaching as a way to break up your things. The examples are always followed by practice. So you've got lecture, didactic with mimesis, all those things. I could ask a question like this, what is that weird E symbol? What does it mean? And why are the numbers on the bottom and top? What is that telling me? You could try to ask those questions, even to see what students know, assess prior knowledge. So all those things. Feel free, again, to take that idea, start breaking it down, rework it, steal an idea from there and throw the rest away. I don't care. Just wanted you to try to see how it pieced together. You could throw board work questions. Like I said, I am out of time and I wanted to have a little bit of time to talk. You could go a lot of places with this. And again, there's a lot more methods. You studied some of them. I didn't even talk about things like giving them a problem of the day, right? Start by a problem of the day or bell work. I didn't even touch those. Those are didactic or memetic. They can become Socratic if you do them right. All those are things you can do, and they all fall within this broad scope of classical because remember, our goal is to give them the tools of learning they need to be independent learners and appliers of mathematics. I know our time is really short, but I'd welcome any questions or comments, or you can grab me later on and talk with me. Thank you.